This session is introducing the new experience for SageMaker Notebooks. SageMaker Notebooks has been vastly updated as part of the new SageMaker Studio launch, and I want to take you through some of that today. I'm Tom Faulhaber. I'm a principal engineer on SageMaker, and I'm joined by Preston Ghosh.
Yeah, I'm Prashant. I'm from Pinterest, and I take care of the Jupyter environment in the analytics platform. So I'll be talking about how Jupyter is done at Pinterest.
So let me walk through the agenda that we'll go through here today. We're going to start with some introductions. You've heard about us. I want to hear a little bit about you folks and understand what we should be talking about today, because we'll adjust a little bit depending on your interests. And then we'll do a little overview of sort of where SageMaker is generally and specifically on notebooks. And then Prasoon is going to tell us all about the experience that Pinterest has had and the sort of evolution of their notebook platform, which is a pretty interesting story, and tells us about some of the challenges in building and deploying notebook solutions. And then we'll go into sort of what all the, not all the new features, because there are a lot of new features, but what some of the highlight new features are for the new SageMaker notebook environment. And then, because it's always fun to do a live demo on stage, we'll do a live demo on stage. So that's the start. So before we start talking too much, I want to learn a little bit about you. And this is a little challenging today because the lights are like right in my eye and I can't see who's doing what, but we'll do our best. So the first thing I want to know is how many of you are, or how many of us, I should say, are practicing data scientists? Okay, so not a ton. That's fascinating. Yesterday's crowd was about half data scientists. I guess data scientists wear out earlier or something. How many folks have done some data science or are interested in data science, like to play around with it? Okay, so a bunch more like to play with data science. Cool. How many folks support data scientists, build maybe ML infrastructure or other things? Okay, great. How many of you anticipate doing so in the future? Yeah, okay, so that's a good mix. Who knows what Jupyter is? Not the planet. Okay, so most people know what Jupyter is. We'll talk a little bit about that, and we'll actually see it for those who don't. How many folks have actually used Jupyter? Okay, so pretty good knowledge about Jupyter. And then last question, last pair of questions. Who here has used SageMaker? Okay, so only a few of you. Do any of you have it in production? Wow, really different. This is why we ask these questions. Really different crowd today than when we did the first repeat of this. Okay, great. So we'll go to that. I want to talk a little bit to begin with about sort of the SageMaker umbrella and where this talk fits in and where the stuff we're going to be talking about today fits in. So SageMaker is actually a family of different capabilities, all linked together, all related to machine learning and data science that we produce. There's been a lot of new stuff this week, all under the sort of SageMaker Studio IDE idea. Tons of stuff. There's sessions on all of these. I'll give you references. I think some of the sessions are still coming up at the end of the talk if you want to see some of the other stuff, but a lot of exciting stuff we announced this week. And so that's going to be coming out. But right now we're going to focus in this talk on the new Quick Start notebooks, okay? So to give you some context, some of you probably know this already, but for those of you who don't, we launched SageMaker 2 years ago. Right here at reInvent in Las Vegas, surprisingly enough. It was sort of a new idea to launch an AWS service in Las Vegas. We launched it with 3 capabilities originally, which was notebooks, training, and model hosting. And we've added a ton of capabilities since then. But notebooks have continually been sort of one of the really successful features of SageMaker. Customers really like them, and they've gotten a lot of use. We get to see how people use them a lot. And so what we found is customers like notebooks a lot. They like Jupyter, but they want more. And so, you know, we want to give our customers what they want. So we sort of went back and started thinking about, like, how can we build a service that's all the goodness of what's in SageMaker notebooks, but a bunch of new stuff. So that's what we're going to be talking about today. It's in public preview today at SageMaker Studio. You can find it on your console. And it's actually today, it's only in the US East 2 region, but it will be rolling out to the other regions over the next few days. It'll be generally available early in 2020, so not very long. And I'll talk about, as we go through, I'll talk about which features aren't there quite yet and which ones will be coming as we get closer to the general availability time. So Jupyter. Jupyter is a great open source interactive notebook. It is, I should actually know the answer to this, but it's about a 9-year-old project now, if memory serves me correctly. And Jupyter's been very popular in a lot of contexts. People have been using it for a lot of different applications, but it's been particularly popular in a sort of exploratory data science. And so when we started to do notebooks back in, whatever it was, 3 years ago when we started this project, Jupyter was sort of the obvious choice to build our notebooks around. And we'd all used Jupyter, but we weren't sort of that invested in it. But as we got in deeper, we realized Jupyter and the open source community around Jupyter is really, really important and really valuable. And as we went to customers, they were like, yeah, this is great. We want Jupyter. We don't want you to do something different. We want Jupyter, because Jupyter is open source. Everyone's involved in the development. We use it not only in SageMaker, but we may be using it in various on-prem services or just on our laptops or wherever. It's nice to be doing the same environment. But our customers challenged us to really help make Jupyter better. And so we heard that. And so the new version of SageMaker Notebooks is entirely built in SageMaker Studio. It's actually entirely built on Jupyter Lab, which is the latest UX experience from Project Jupyter. And we've become increasingly active in the Jupyter community itself, contributing code. Two of the steering council members are now, including Brian Granger, who's the co-founder of Jupyter, are now working on our team at AWS, which is fabulous. And they're working both on sort of the AWS direction, but also still working a lot of their time on the open source, contributing to the open source community. We have a number of other engineers contributing to the open source community now. And we just recently became a sponsor of NumFocus, which is the umbrella organization over Jupyter and NumPy and some of the others. So there's a set of support that we really believe in what Jupyter's about. So with that sort of preamble about this, I want to turn it over to Prasun to talk about the voyage that Pinterest has had.
Hello, everybody, and thanks, Tom. Here I'm going to talk about how we evolved Jupyter at the Pinterest. So first we'll start with the evolution story, how it started and how it changed. Then the solution for the enterprise data science team, like what are things you need to be aware of while implementing Jupyter in your data science team. Productionizing the notebooks, we have an internal application called Reports. And that's what we use as a production environment for running it on a schedule and integrating with other APIs. The security aspect of Jupyter, like what are things you need to take care of in terms of security. And also the Jupyter image distribution and environments. And finally, the open challenges that we still have at the moment. So the Jupyter evolution at Pinterest, it can be broken up into 5 different stages. The stage 1 is where you have database clients, some scripts, some ad hoc applications, and you pull data, keep it locally, run some query, generate output. It works. The next stage will be the setting up local Jupyter, R-Shiny or RStudio, setting up the Jupyter instance, a global instance with internal data clients will be the stage 3. And stage 4 is setting up a Jupyter cluster. And stage 5 is customized Jupyter with workflow and scheduler. Now the stage 1. So the challenges with this particular stage where you have database clients, you pull data, you run some scripts, application, and third-party software is that everybody needs to do a lot of bootstrapping. And that makes it very challenging to distribute your work. And it is not optimized for the data science team. It is not flexible. And the most important thing is it is not consistent. Everybody does in their own way. In the stage 2, you set up a local Jupyter instance, and it is more polished because you have Jupyter. You have a standard way of showing the output, and it is frequently reproducible, hopefully, because you have to install the associated libraries, and it is consistent to some extent. The con side is that it is still not very much shareable. All you get to do is share the output, not really the notebook, because the other person needs to have all the libraries in there. The learning is very limited because the other person may not be able to run your notebook as is, or maybe modify it and rerun it. So learning is very much limited. And the complex process of sharing, like I have seen people taking screenshot of the charts and putting it into Word document, then sending it out in email, and it's complicated. The stage 3, this is where you have a global instance of Jupyter in your organization, and you have a common shareable EFS, and everybody is running, being able to see the same notebook, and they are sharing the memory space. So if you run a notebook, another person goes and sees the notebook, they're actually working on the same notebook, same memory space. And so the ease of access is now much more and better exploration. The limitations are that users are now overstepping. So since more than one guy is accessing the same notebook at the same time in the same memory space, they are overstepping each other. And the usage of the hardware is very uneven. So since everybody is going to work on the same environment, you need to have a very high-end system. We had one with 480 GB RAM. And when it is on peak use, you can get into out-of-memory situation. And when it is not used, it's totally a wastage of such a huge amount of memory. So the out-of-memory and out-of-file handles were like so frequent issues in that stage. We were only busy attending that kind of issues and could not develop much. So it is still very vulnerable. The stage 4 is where you have individualized environment using a Kubernetes cluster on Jupyter Hub, and everybody gets their own memory space. We are still using the same EFS, so that way you can share the notebook. And the runtime is separate and less failure. We rarely see any failure happening at a global level. So multiple centralized image distribution was a big challenge at that phase, and users still oversteps each other because we are using a single EFS. So that means if you save your notebook, you might be overriding the changes made by other person, but that's only at the storage level. The stage 5 is where we are at the moment, and we have Jupyter cluster with dedicated runtime environment with workflow and scheduler. The ease of distribution is now a lot more better. The output is consistent. The workflow and scheduler is in a particular application called reports. So you can just share the reports link, and they have all they need. And you can see the historical change. Like if you have run this notebook like 2 years ago, you can see how the output was and how the output is now, what all things have changed. Access control is still not 100% done, although we do provide some level of access control, which I will cover later on. And the ecosystem is complex. We are still hopping through multiple applications to get to the end result. Like you do it in Jupyter, then you do some review in the version control system, and then you run it in the report application where the end users get to see your output. So the solutions for the enterprise data science team should include following things. One is the ability to share notebook. We are using EFS with a common image distribution. And since the image distribution is controlled, it is backward compatible as much as possible. The notebook backups, you can do daily backup, which is a separate process, or you can do it as a backup on each save. Versioning of the notebook, we created our own version control system just for notebooks, which is based on S3. But you can also use Git or some custom extensions or some checkpointing. Review and commenting, we customized our NB time with features for providing threaded commenting by multiple users. And then there will be a set of users who can accept the particular version of the notebook. And that's when the next point comes up, the release of the notebook to production workflow. So a particular person with a role of ability to release the notebook to the production system will publish it. So access control is very much there. Other things you need to take care of are the performance and usage of the logging, usage logging and analysis. This helps a lot in terms of cost reduction because you get to see who is using how much and how we can improve on that. You can even suggest certain improvement on the notebook performance. Like if a query is taking like 7-8 hours to run, maybe we can break it up, do it some other ways. We can prioritize features one over another based on the usage. And we can also do an easy postmortem of any kind of incident that may have happened. Caching helps a lot. Instead of running the same query again and again on the database like Hive or Presto, we used caching, which expires on 7 days with the S3's auto expiring system. So we are like, if you have run a query that took like 3 hours and you're trying to rerun the query, or somebody else is trying to rerun the query with the same set of parameters, now it takes like 5 minutes to download the end result from the cache. That helps a lot. Indexing and search, that's very important because we have like around more than 23,000 notebooks. And it is very important that we are able to reuse the existing way of implementation. Like somebody used some DS library to render a chart. You want to know how that person did it and probably copy that thing and improve on that. So indexing and searching helps a lot. So we are using Elasticsearch to store our indexes. And we have a separate interface from where you can query and see the output. So this is the notebook life cycle. On the left, you have the Jupyter on Jupyter Hub, where you can create, compose, edit your notebook. Once you are happy, you check it into the Jupyter version control system, where you check in. Then it undergoes the review process. There you can create diffs with some older version, see the diff, and then comment on that. Finally, there will be a user who will accept it. And then there will be another user who will publish it to the production system, which is on the right. There you create a report. When you publish a notebook, it automatically creates the report. Once the report is created, you create parameters, how to run the report, and create schedules, like at what schedule you want to run it. And then once it is done, you can view the report. So productionizing of the notebook includes following things. One is parameterization of the notebook. We are using an internal args library for that. Scheduling execution of the notebook. We are using, our reports application is written in Go, and we are migrating it into Python. We are using the Go's cron library for that. However, we are also trying to use the Airflow, or we may use our own Flow Hub for external scheduling. The workflow integration of the notebook via REST API has helped a lot. We have multiple workflows like Pinflow, Pinball, and we have integrated our reports application with them. So as part of the workflow, it gets executed. The report application might be creating some charts or some data, which is used by the downstream job. Access control list, past execution history. That is also an important thing, as I mentioned, that you can see how a report output was 2 years ago and how it is now, and you can compare an output. Access control list allows you to define who can view the report versus who can execute or who can change, like upgrade the version. And run notebook on separate pods, that helps a lot. Each notebook is run on separate pod, unlike in Jupyter, where you run all the notebooks in the same pod. In this case, each notebook is run on a separate pod. That helps a lot because some of the reports might be needing an image which is like 1 year old with certain older version of library. You really don't want to touch them because it is working fine. We just want to run it, that's all. You want to get the output. So sticky images helps a lot in that kind of situation. On the security side, we have Pastis, which is a centralized authorization framework, which ensures that only certain people have access to certain resources. Envoy is a service-to-service proxy with MTLS that ensures only certain network of application can access other services like MySQL database in our case. Knox key management, it is open source for Pinterest, and that's used for storing secrets and accessing them. Impersonation, we access our Hive or Presto with an application user ID, and then it uses impersonation to identify the actual user. And that ensures that only certain people have access to certain set of tables. OAuth with LDAP, they work hand in hand, and that is used a lot for ensuring that only the right set of people have access to the Jupyter instance and reports instance. TLS is our service-to-service communication mode. We ensure everything is encrypted. IAM role is used a lot for accessing any internal resource. And security group and security zone ensures that network level access is maintained. The Jupyter image and environment, we have a Docker multi-stage build. So we have kernel for each of the teams within the organization, and they contribute their own set of libraries that they want to use. So they are all independent builds happening. And then at the end, we merge those independent conda environments into our one single Docker image where all the environments are there. So since each team has their own kernel and each notebook is bound to a kernel, anybody can click on a notebook and see the output. You don't have to be part of the team to be able to see the output. But at the same time, you are using a different environment for that particular team. The build stabilization, we are using a beta set of users. They have volunteered to look into our generated notebook image, and only when it is stable that we send it out for the general release. We have multiple environments. Obviously, one is for the PIA, which is very much access controlled, and other secured environments that we are coming up with. So this is how the image build is done. As I mentioned, we have the Jupyter Docker Stack image, and then underneath that is the Jupyter code. That's where we add in our plugins. So we have our own set of plugins for version control and all. And then we start creating images for each of the team, and they add their own libraries in there. Finally, at the Jupyter full stack, we just pull the conda environment for each of the teams and merge them into the main image. And that is what is distributed. These are still the open challenges we have, and we are working on it. One is evolving complex access control. We are not sharing, not just within the organization, we are sharing outside the organization too. So that has added newer challenges. Team-specific workflows, every team has their own way of doing things. So adapting to their workflow is very important. Library conflict resolution, and it is probably never going to end, but we are trying our best to make it as small as possible. And solving learning curve for the users to increase adoption speed. This is where we are training our internal users, doing brown bag sessions and office hours so that everybody is aware of it. Obviously, the indexing and search is helping a lot on that. Thank you.
Thanks. Okay, so how many of us have done some part or all of this voyage that Prasanth was just describing up to serving? Yeah, so there are a couple of us. In my pre-AWS life, I would have raised my hand too. So at AWS, when we see this sort of pattern repeating over and over, where people are forced to re-implement sort of fundamental infrastructure services to be able to deliver something, we see that as an opportunity to do it for people. So one company does it, everyone doesn't have to. And that's sort of where we're going with SageMaker notebooks now. Those of you who've used the existing SageMaker notebooks product know that what you have is you basically have an EC2 instance that you can start that will manage for you, and we'll make sure it has the right Jupyter and everything else and the right environment on it. But you're still thinking about an instance, and that's got some pros and cons. One of the cons, actually, is it's not very fast to start. So the new platform works much more like a web service, a web application, rather, that you would think about, I want to open a notebook, I just want to run. I don't want to wait for a long time. I don't want to think about the notebook a lot ahead. Because when you think about what makes it slow to start a notebook, there are really two things, right? One is in SageMaker, and this is true of a lot of services kind of like this. One is, what's all the bureaucracy I have to do just to sign up and register and configure and do this, right? And do I need to decide what kind of instance I want now for the work I'm going to do in 2 weeks? Or am I able to just sort of change things in 2 weeks very easily? So part of our idea around making things start quickly is to have it work, again, more like a web application. You open SageMaker Studio and you get a notebook. You can configure how that notebook runs later when you want different parameters to it, and it will change under the hood. And we'll talk more about that as we go further ahead. The other thing is the actual startup time. So we're doing a lot of work, some of it's in the preview and some more of it's coming over the next couple months, about just accelerating the time it takes to bring new compute online and give it to you with a full Jupyter and all your kernels and everything you want in place. So those two things go together to deliver an experience that feels quicker. Now that actually has a couple of advantages. One is, of course, instant gratification, which we all like. The other one is, if I feel like I can turn on the notebook more quickly, then I'm comfortable turning it off when I'm done doing something, because I know when I come back, I can quickly get back in and get up, and it's not a big delay. And that has a big cost impact, right? So for those of you who are in a position where you actually care what things cost, I'm usually in that position myself, this is a nice feature because it makes it easier to just sort of go in and go out and, you know, flip it on and flip it off. Another thing that we found when talking to customers who are using the existing SageMaker product is that most customers, especially the larger customers, tend to put whole teams of data scientists in a single AWS account. How many people here do that? Yeah, fewer than I thought, actually. When the whole team is in one AWS account, suddenly things get confusing. Some of the problems that Prasanth was talking about earlier about people stepping on each other and notebooks getting confused and who owns which notebook instance and do I need to create a new instance for every user, and all these questions come up. How do I know who did what thing if I need an audit trail? So, excuse me, I've been talking all week and I'm beginning to lose my voice. The new SageMaker notebooks has the notion of users baked in. There are a few different ways because different organizations deal with users differently. We're integrated with AWS SSO, which gives you the ability, single sign-on for those who aren't identity nerds. I unfortunately have become way too much of an identity nerd in the last couple of years. With the SSO integration, you can, for example, attach to your organization's Active Directory or whatever your other identity provider is and use that as your source of identity and enable certain users for SageMaker notebooks, and then they get their own identity within SageMaker notebooks, and you know, this was Prasanth or this was Tom. You can create your own user pools within your AWS SSO. You don't have to connect to an external identity provider. So if you just have a little data science team and you want to come in and 5 of you want different users, you can just set that up in like 5 minutes. Don't quote me on the exact times, but it's really easy. And then you all have your own user identification. You keep track of what's what. Users can have their own roles that are assigned to them. You can assign roles at the account level, at the group level. You can have groups. Or at the user level, or all, right, and have the overrides you'd expect. And so there's administrative tooling around how to go set these permissions. So there are different things you set. You set roles. We'll talk later. You can say what kind of compute people can use and some different stuff like that the administrator can configure. So this sort of brings me to a different point, which is that as we look at Jupyter Notebook users, right? A lot of Jupyter Notebook users are individuals who just want to do some data science, right? So I want to get on something quickly, I want to do data science. Other users are small data teams. I mean, they're a startup or an organization where they have a small data team. They want to work together on something and go. And other users are in larger enterprises like Pinterest or probably some of the enterprises you have, where there's dedicated IT support who's supporting, one or more data science teams to deliver this. And there may be, especially in finance or healthcare, there may be strict compliance and security requirements. So it's important to note within that the new SageMaker notebooks has the same high security bar that the existing SageMaker notebooks has, right? So you can do things like network isolation and sort of all these other features that we've had, as well as sort of, encryption everywhere and all this good stuff. So for organizations under compliance and security regimes, that's pretty important. So each of these users has their own home directory. So this is sort of a key difference where in the old SageMaker, every instance kind of had disk, and you could maybe manage your own sort of centralized repositories if you want. With SageMaker notebooks, every user in the account automatically gets a home directory. It's in EFS. We manage sort of the user mapping and all the POSIX UID stuff so that who you are on the notebook matches who you are in EFS. Even if you bring your own, and we'll talk about this a little bit, even if you bring your own environments with maybe their own user idea of who the user is. So these home directories live there. If you are using multiple compute in different places, and we'll talk a little bit about that as we go forward here, they all see the same view of your home directory. So it's always there, tilde always has the same files in it, no matter sort of where you are in the environment. So this lets you run distributed computing applications, but then see a single file environment. So like almost everything in SageMaker, the home directories are actually in your account. And they're in EFS, which has a huge advantage that you can use the data that you create in SageMaker notebooks in all sorts of other places. So you may have analytics jobs that runs off data that you create from your notebook, or that dumps data into your home directories based on some previous run. You can just mount EFS and put it in there for you, et cetera, et cetera, et cetera. Excuse me. So one of the big things we hear about, and Prasanna was just talking about it a minute ago, is people like to share notebooks and results. Now, the first thing, and we keep getting requests, we hear about implementations, there's a lot of noise would be pejorative, but there's a lot of talk about notebooks and how to share them and how to collaborate in notebook environments. And one of the things we realized as we dove into this space was when people say, hey, I want to share notebooks or I want to collaborate on notebooks, 20 people in a room probably have 20 different meanings of what that is, right? Maybe I want to share a report with my boss. Maybe Prasanna and I want to collaborate on a new model we're working on, perhaps even in real time. Maybe I want to be able to have a group Git repository that works well and seamlessly so we can all be working off a common base. Maybe we need a set of common modules we're working with, and we want that maintained for us. So there are a lot of different meanings here, and they're all extremely valid, right? They all represent real important use cases. And we're working on a bunch of them. The preview has a first version, which allows you to share notebooks between users within an account in a fairly seamless way. And we'll watch that in a little bit. One of the important parts about notebook sharing, we'll talk a bit more about environments in a minute, but when you share a notebook, it's the environment that it was made in is shared too. So if I had an environment where I had a bunch of stuff installed and I share my notebook with someone else on my team, they can immediately open it and use the libraries that were already there. So the next couple slides describe things that aren't in the preview, but we have in the lab and will be part of the final product. Whenever I say in the lab, I imagine we all wear lab coats and have test tubes and stuff, but it's not how it works. So I just touched on environments. One of the key features of the new SageMaker notebooks is environments are customizable. So you run in environment. We provide, I think, 5 pre-created environments, a basic Python environment, a data science environment, and 3 deep learning pre-configured environments. But as you run in there, you can install new software, you can do different kinds of things to that environment. And of course, your home directory is always there, right, across all the environments. It's still your home directory. But the changes you make to your environment are probably specific to that environment. You don't want, if I add some TensorFlow plugin, I don't want that to show up in my PyTorch environment. It makes no sense. It would confuse things, right? So you can think of the SageMaker environments as sort of like a Conda environment on steroids. It can capture all sorts of things, not only Python things, but things outside Python. And then that stays with you. So as you keep using that notebook, or if you use that, if you move to a different type of compute, or you share your notebook, the environment you've created stays with you, and it's still there. So that's great. I say administrators here, actually. Administrators is a funny word in this context, right? Because there are lots of cases where I'm just self-managing what I'm doing. I'm a data scientist who wants to do stuff, or maybe we have a small team and we take care of ourselves. In larger environments where there may be more rules about how people live, there are actual formal administrators, or sometimes it's like machine learning infrastructure teams, or different roles that people do to do this. But one of the key things here is folks can create their own environments. So we talk to a lot of people who have, we have our data science, we want to give them a quick start. There's a set of libraries that we use for all our projects here, or maybe what Prasanna was just talking about. Each team kind of has a different set configuration. That's their starting point. And almost all of them say, but we just want it to be a starting point, because then people change what they're doing, and we don't want to have a bureaucratic process where they have to wait for us to bake it into their environment. So the idea here is that you can create a new environment. You can do it either through our APIs, where you just define it, or you can have a more traditional Docker CI/CD pipeline that's generating your environments and maybe running test scripts across them and so on, like what Pinterest has. And then those can be injected into SageMaker as is. You don't need to do anything special. You add a little bit of metadata when you add it to SageMaker to say, hey, this is a Python environment. You can run a kernel in here, a Jupyter kernel, and it will work. And here's the name of it and some other stuff like that, right? And that's just metadata you put on. And then you just point it at a Docker repo, or there are a couple of other ways to do it. So that's nice, because you can start with your own version for your own team. You can update it when you want, and people can add to it. Okay, now flexible compute. So one of the things that's always been a headache, pretty much for all AWS users, is picking what kind of instance to run on. And this is especially difficult for notebook users, because it's like, okay, what am I doing today? What am I doing tomorrow? I'm going to get a new project on Monday. I'm going to try and go look at a different data set. This or that. They may require different instance types. And actually, to be honest, I don't even know, right? It's like, well, this one has 8 gigabytes of memory, and that one has 32 gigabytes of memory. How much do I need? I don't want to spend more money than I have to. So part of our goal with SageMaker Notebooks was to make that much less of a problem. So with SageMaker Notebooks, you start with a small, inexpensive instance. You're running. At any time, it's not in yet, because we actually took it out because it wasn't done, but it'll be in soon. It'll be back in soon and working, is we have a drop-down to change the compute. And we have recommendations on sort of basic compute that users want, because we understand that the set of AWS instances is pretty daunting. But users who actually have specific preferences, it's like, I know I'm an AWS instance expert, and I know for this job, the C5 8X large is the computer for me. And a lot of us have been there sometimes, and usually we're not. You can go do that too, right? So the instances start fast, kernels are loaded fast, and you switch. So I can be working along, classic example. I'll give you 2 classic examples of this. I'm working along, I load a data set. I try and do a pandas operation on that data set. What happens? Oh, I'm out of memory. Okay, system's not big enough. So in the current world, it's like go find a bigger computer, right? At least that's easier in the cloud. I can go find an EC2 instance or a SageMaker instance that's bigger, but still it's a big pain. I got to move my files and do all that stuff. In the new SageMaker notebooks, what you do is you pull on the drop-down, you select a larger instance, and we're working on UX. It'll just let you say, give me a larger instance of the same kind I have now, and 30 seconds later, you're up and running the larger instance, and off you go. The operation is very similar to, if for those regular Jupyter users, just restart the kernel on the notebook, except now it comes up on a new beefier instance. The other example that's pretty common is the example where I'm working on a big deep learning model, right? Really wants to use GPUs to be efficient. Maybe it has a ton of input data that it's pulling from S3 at runtime. So you have this whole sort of large-scale thing. But I'm a data scientist. I'm basically messing around with the model 90% of the time and training it about 10% of the time. So in this environment, there are 2 solutions to this. One is you can write it using the SageMaker Python SDK and just actually push the training to SageMaker training. That's sometimes not as great if you're sort of in exploratory mode where you want to actually interact with it. So in that case, what you can do is you can do the training right there in the notebook. You can run on a small instance while you're writing code and maybe testing it on very small data sets. And then when you want to go test it on a real data set, go to your drop-down, pick a, let's go large, pick a P3 16X large, run that for a 2-hour training run that would have taken you 3 weeks on the smaller instance. Well, actually, it would have just run out of memory on the smaller instance. And then you get your results, and then you can go back to the smaller instance and, figure out what your next course is, right? Big part of our goal is to make this kind of compute power more accessible to more people. And one of the ways to do that is to really get to a pure pay-as-you-go way. That works well with SageMaker training now, but that's sort of another service you have to interact with. We wanted to make it work well with notebooks too, and that's what this is about. So that's flexible compute. I think it's time to look at something running, because we've looked at enough PowerPoint for one day. So let's see. I think that's the right button. Ooh, look at that. Now that is an exciting product. You can't see it because, projector scale, but way up on the top there's a little bookmark that says Jupyter Lab. So I'm going to start from scratch here. Okay, Jupyter Lab. Ta-da. Okay, so this comes up. When I signed up for SageMaker Notebooks, I got a URL. I can also go through the console. But one thing that we've heard, I didn't actually talk about this when I'm talking about users. One thing we've heard from a lot of, especially larger customers, and by large I don't mean super large, everywhere from sort of medium-sized to large, is the DevOps team and the infrastructure team say, we don't want data scientists on the AWS console, right? We don't trust data scientists to be there. We don't want to figure that all out. And they're not even bright enough to be there anyway, right? And the data scientists, on the other hand, say, oh my God, the AWS console is for total geeks. We don't want to be on the AWS console. So there's broad agreement, different agreement about, who's cool and who's uncool, but there's broad agreement about no data scientists on the AWS console. So an important part of the new SageMaker Notebook experience is you don't actually have to go to the console. And in fact, this isn't only for notebooks, this is the whole SageMaker Studio initiative, is it's really a data science-centric environment. You come right in here, you have a URL. Now you can go through the console. If you're on the SageMaker console, there's a button for SageMaker Studio and you can launch it. There's still a lot of administrative functionality on the console. So one of the things I didn't mention, although there was a bullet, is the administrator can, for example, say, hey, we don't want our data scientists, burning up the budget by running lots of big P3 instances. Let's not give them access to that, and you can turn that off, and then turn it on selectively when there's a good use case for it. But generally, the data scientists will come right here. They'll log in. As I said earlier, this could be linked to Active Directory or something else. In this case, I've just created a little user pool in my account. The user? Not yet. The name is guaranteed to be unique, so you'll never collide with anyone else in the world. So that's the good part. The less good part is we don't have a system for friendly names. We're thinking about whether we can do that, and we're interested in input from folks on what they'd like that to look like, and happy to talk about that some more. Because yeah, we get it that that's an interesting feature. So this is the SageMaker Studio UI. I talked earlier about how we're really involved in Jupyter. And really thinking about Jupyter as sort of a centerpiece of what we're doing. All the SageMaker Studio tools are actually built as extensions in Jupyter Lab, okay? So right here you see we have a basic splash screen. We have the usual that shows some of the things you can do. We have the usual sort of file system stuff that you are used to from Jupyter Lab. How many folks here have used Jupyter Lab before? Okay, so what you see here is Jupyter Lab, if you haven't seen it before. It's different than Jupyter Classic in that it's more like sort of an IDE environment with tabs inside and where you can move things around. You can actually move chunks. You can say take the output of your cell and move it into a different tab and make windows on the screen. There's a lot of fun stuff you can do. We have our own theme for it for Studio. But it's got all the usual stuff you'd expect. It's got the Git plugin, which is one of the things we've been working on at AWS as part of the Jupyter community, is to improve the Git experience in Jupyter. And we're continuing to work on that. Command palette. This is the main Jupyter SageMaker Studio panel. You can see experiments that I've run. These are some autopilot experiments I ran. So this was an auto machine learning job that I ran. Actually, as part of a launch pad we did down on the show floor yesterday, or 2 days ago. And one of the nice things here is whenever I'm training with SageMaker training and so on, I automatically get experiments made in this environment, and I can go explore them. That's not this talk, that's another talk, so I won't go any further on that. And then so on. But one of the things that's interesting, and I just got this email from Nicole, is sharing. So Nicole and I were talking about normalization of eigenvalues the other day, which is a subject you can't help but get excited about over lunch. And she remembered, hey, there's this appendix in Dive into Deep Learning, which is a book that Zach Lipton and so on wrote that has a total online component. It's really actually pretty cool stuff. And she just shared the notebook with me so that I could look at it. So I can now just click on that notebook, and it gets shared over here. Ta-da, go. And so what I get is I get a read-only preview of the notebook. And I can go down and find the part on normalization, which is down here. And so this is the read-only copy. This is just a view. And this is nice because it doesn't change anything on my system. I can just look at it and see if it's something that's interesting to me. But then if I want to actually work on it, I just hit create a copy. And there I am. You see it's popped up into my file system, and it's now I have my own copy. This copy is now not tied to anything Nicole did. So important part about sharing. When Nicole shared that with me, she took a snapshot of that state. She can continue working on her copy. We've saved a copy in the back, so she may do other things. You know, maybe she's going to send a message to Prasan about some other thing that's built on the same notebook, maybe with a different data set. And so she doesn't have to worry about breaking what she shared with me. As we talked about, there are a bunch of use cases in sharing. Sometimes that's the semantics you want, sometimes it isn't, but that's the current semantics, and it is sometimes what you want. Then when I get it, if I start making changes, I make my changes in this local copy. And now I can run it, and I can just start executing cells. Oh, except, yeah, okay. Except I didn't have it set up right. But I can execute cells and do all this other stuff. So voila, it goes. And that's great. And then if I want to share something back with someone, maybe I now want to share this notebook with someone else, I can just click on the little icon here, and now I can share it. I have some choices. I can include connections to the underlying Git repo if we're working in a team that is using Git to back. Again, Git and version control is something. It's like sharing. It's like everyone wants it. Everyone has a different definition of how, especially with data science, as opposed to software engineers, how they want to integrate with this. And so we have some knobs you can tweak to be your way. This one, I just received it as sharing, so there was no Git repo in it. I can include output or not include output. And this is actually also an administrative feature. I can turn off the ability to include output. In some compliance regimes, for example, I work in healthcare, people want to make sure that people didn't do a query and have the PII data in the output. Here I want to include the output. And I just create it. And now I get this link that I can just copy, and I can throw in the Slack channel or throw somewhere else that will get them right back to this notebook. And then, as I said, we'll close that and I'll copy that link in case I want to use it later. We see here we can change the kernels in the normal way. In the future, there'll be a little block right there to change the instance. We have the block for diffing this against Git. This one isn't in Git, so this is not enabled. And then we have all the usual toolbars that are there. So that's what we've got. Let's go back here. We'll go here. Oops. Nope, I have the thing upside down. Hold the clicker the right way. So there are a bunch of related breakouts. I don't know how many of these are still on the forward schedule. I know, unfortunately, AIM230-R1, which I would have strongly recommended, started 5 minutes ago, but that was Brian Granger. Maybe it'll be on video, talking about Project Jupyter. Brian Granger is the co-founder of Project Jupyter, who joined us last winter and has been awesome as part of our, sort of engaging with the Jupyter community. We started talking to Brian and then realized we all had the same vision and we should be working together. But there's a bunch of great stuff around SageMaker. If you don't get to see it here and you want to see more of the features, feel free to grab those on video after the conference. We've done a bunch of work integrating SageMaker capabilities into Kubeflow and Kubernetes, which you can look at, and then if you're bored later this afternoon or you're still here tomorrow, I'm actually giving the same talk twice on unsupervised. And you like listening to me, which is a big if, right? But I'm going to talk about unsupervised machine learning. So there's a long if chain there, I guess. But yeah, so that's stuff coming up. So thanks a ton. It's been really great to talk to you. We have about 9 minutes for questions. I will remind everyone to complete the survey because, they like to see whether you like what we're talking about. But until then, questions. Do we have a mic for questions, or are we just going to yell it out? I'll take that as we're just going to yell it out. Okay. I'll try and repeat the questions. Okay. And the problem is I can't see, so wave your arms around pretty energetically.
Is there an option on the IDE for local execution? Like, say my laptop has access to data sources that the EC2 instance would not have access to?
No, not yet. Right, so it's something we've been thinking about how it would be structured and what would make sense there. We've played around with some ideas. We're interested in input on, what it would look like to you. But yeah, currently it's pure cloud-based execution. Okay, now you get to go again. I'll try and actually see the whole room so I can get everybody. That's exactly right, yeah. So it's just in the VPN that you specify to run with. In the quick start, it just starts in your default VPN, but the administrator can set you up, VPC. Sometimes I get the Amazon terminology wrong, even me. If you can actually build your SageMaker Notebooks environment into a different VPC if you want, and the EFS will be there. So just depending on what your network configuration is, and then you can just go ahead and mount the EFS. I have, for example, all this data. I have a EC2 instance in US East 2 that I play with that disk with too. No, from EFS, the UIDs are just what they are. By default, the EFS is locked down in a security group to only SageMaker Notebooks. It's just a security group edit to change it that an administrator with the right privileges can do. And so you just sort of unlock it for the rest of the account. And then mapping UIDs, because EC2 doesn't support single sign-on yet, you have to do it yourself, right? Or sudo and do all that, right? So as you open up EFS, depending on your security and compliance environment, you want to think about, how am I opening this up? That's why we close it by default, is to, say, hey, open this up, feel free, but do it consciously. And it's going to be different if you're in a large financial organization than if you're 4 guys in a garage, right? Way over there in the light. No, it's actually not an IAM username. Well, it depends, actually. One of the things I didn't talk about in user management is we support both SSO and IAM. There was a bullet on the slide, but I got excited about something else at that point in the talk, sorry. We have, the sort of easiest way to go is just use SSO, and you create users. I create Tom and Prasoon and Nicole and Kevin and, whatever the team looks like. And they get an email. they respond to the email, they enter a password, and they go, right? Standard sort of sign up for a web application kind of thing. And then they're all users in that account. And you can do that either by creating those users in a SSO user pool or by connecting the SSO user pool to an identity management system outside. So various organizations have already built solutions around IAM to do user federation. And so because of that, we also support being able to create users that are in the IAM space, right? So if you use, sort of a third-party authentication system to come into AWS that maps into IAM roles underneath, you can use that to go in. Oh yeah, good point. So every user that you define within SSO, right, that you enable for SageMaker, you can also attach a SageMaker, a role that you want that user to use in SageMaker. So you can, and you can do that, you can say, oh, this account is for, I don't know, the San Diego data science team, right? And this whole team has access to these buckets and these databases, and there's no real difference in what they're allowed to access. We want to audit who's who, right? But there's no difference in permissions. You just set an IAM role for the whole account, boom, done, right? Other times you may be like, hey, there's 3 groups of data scientists in here, and they have access to different stuff, put all the users in groups and go, right? The last case is, hey, Joe's working on a special project and he needs access to this data, but it's pretty sensitive PII data. Let's just give him access to that data and leave everyone else at the default. So that all the combinations are possible. So they don't, yeah, I mean, it's not actually an LDAP group. The SSO has its own idea of groups. And there's, I'm not enough of an identity nerd to explain why that's true. The SSO and IAM team have tried to explain it to me, and I nod my head sagely and go back to thinking about machine learning. But I think machine learning is complicated. Wait till you get to identity solutions. So, yeah, back there. Uh-huh. So I will confess it's been a while since I've thought about the different capabilities, right? I think, they're definitely in the same category, for sure, right? Domino's done some great work. We love what they do, and they're a great partner. So it's, I think of SageMaker in some ways more as sort of base tools for doing your job, right? I mean, it's the AWS thing. We want to build sort of the base building blocks. We've made it look nicer than a lot of AWS services maybe, so it might be confusing about that. But I think that you'll see a certain amount of overlap, and the difference is you'll just have to evaluate yourself, right? I mean, Domino does some different things. I know about how they manage algorithms that you're running, and some of that. The experiment management is a little bit different. I don't have a strong opinion about which one is better at the moment. I haven't gone and dove in on that. And we'll both be continuing to innovate, and we'll be looking for ways to work together with Domino as well. We've already done some, and I expect we'll do other stuff. Yeah.
What's the major advantage for SageMaker comparing to the Kubeflow, the open source Kubeflow?
Well, I mean, the first advantage is you don't have to manage computers, right? So SageMaker is designed to be really, it's not a system for allocating jobs to clusters of machines, right? It's a system for running jobs through an API. So there's a really different philosophical idea there, right? And the huge advantage of that is I just run something, it runs. If I need to run 100 things, I run 100 things. The compute's all managed behind the scenes. If I need to use big compute or small compute, I don't have to, do cluster configuration and other things. This is an argument in the APIs, right? So that's the sort of high-level philosophical difference. Another philosophical difference, I think, is SageMaker has moved more towards being, we're both container-based. Kubernetes is container-based, and SageMaker doesn't have an official orchestration system, but it's all built on Docker containers. But we've been moving more towards working in terms of source code. For example, if you look at the frameworks in training, you never actually have to build a container or do anything else to use them. You just submit a Python file with your TensorFlow script, and we run that. So philosophically there, again, while the flexibility of containers is important to us, we've tended to focus more on how do we deliver stuff in terms of source code. There are a billion other things. Actually, the last breakout I was talking shows how you can use a SageMaker job as a Kubeflow job, which is kind of nice because then I can have I can use it in a cluster without having to worry about scaling up a particular instance type to take my job, and just sort of let SageMaker do that work, or use something that's just available in SageMaker without having to do it in Kubeflow. And then I think, SageMaker is a little bit more, kind of managed, and we try and make things fit together a little bit better as opposed to being more ad hoc in Kubeflow. And to be honest, both have advantages, right? I mean, you can have a good discussion over a beer about which is the right one. More questions? Okay, let's call it a day. Enjoy the rest of your conference.